Welcome back. This is our MRS22 Spring 2021 Final Review Part 3. And if you haven't had a chance to watch the other two, please do so. All right, so this is our third question we're going to be reviewing for our final. In this case, the function f of x has coordinates -3, 7. If g of x equals -2 f of 3x plus 8, A, name the transformations in the order they occur to go from f of x to g of x. And then B, find the coordinate that must belong to g of x. Use your work from part A. And so here we're going to first identify our transformations. And so our first transformation we're looking at we'll be using our order operations. The first thing we try to identify in this case is going to be a parenthesis. What's in that parenthesis here? And we see the 3 is multiplying the x. So for our first setup, we have our first transformation is going to be a horizontal. Now, it's a compression. Now you say, why is it compression, Mr. Gong? Well, it's compression because we are, when the value number multiplying x is greater than 1, it's a horizontal compression by a factor of 3. So we're going to compress the original f of x by 3 times. So we kind of squished it, if you will. Okay. All right. So the next transformation we go at is going to be again using order operations. With after parentheses, there's no exponents for transformations here. So we see multiplication, and outside multiplying f is a negative, right? You might say -2, but the negative is the next thing we see. And a -1 multiplying f usually means, in this case, it's a reflection in the x-axis. Okay, so -1 is multiplying. Now you might say, what about the 2? Well, the 2 also comes up next because we go from left to right for multiplication. So the 2 would represent a multiplying the function by 2 means we have a vertical stretch. By a factor of 2. Now you're probably saying, well, that's kind of weird. Why is it stretch when, when number is greater than 1 for a vertical dilation? We're stretching the value here. So, all right, by a factor. And so let me close A. So there you go. So, and then finally, the last transformation we have, based upon the order operations after multiplication and division, we have addition subtraction. So by adding 8 out here, we have a vertical. Oh, okay, my handwriting is terrible. Sorry about that, everybody. We have a vertical shift up by 8 units. All right, there you go. You guys named the transformations, and we see here there are 4 different transformations. Now for part B, we're going to be taking our coordinate of -3, 7 and transforming through these 4 transformations to get our coordinate on g of x. See, what happens is we don't know any coordinate except for -3, 7 transformed to all of these 4 transformations. That end result will be the coordinate on g of x. So for B, we're going to now figure out, well, for a horizontal compression by a factor of 3, the rule which you will have to show, all right, is xy transforms to, and for horizontal compression, we're not multiplying x by 3. We're actually multiplying the x by the reciprocal of 3, which is 1/3. Please remember in this case, all right, that when we do any type of horizontal compression or stretching, we're going to be multiplying the x value by the reciprocal of that number multiplying x. So we have here 1/3 x comma y, and so we have our coordinate, which starts off as -3, 7, will be transformed. 1/3 times -3 becomes -1, and the y stays the same. Now we're going to transform this coordinate of -1, 7 And the rule for reflection in the x-axis would be x comma y is going to be x comma negative y, where x value stays the same and the y value is negated. So now we're taking the negative 1 comma 7. Do not do negative 3 comma 7. Then we're not starting from that point. We're starting from the first transform point. Remember this. This is a very, very common error students make. They're going to be, I'll start from negative 3 comma 7 for all these. No, okay, because you're transforming, you're running through all these different transformations. All right, and that's a conceptual error. All right, that's going to be costly in this case. And so here we have, so negative 1 comma 7. Remember, you're going to be taking this point here, all right, and using this, and we'll transform it now using the rule x comma neg y, which means negative 1 stays the same, and we negate the 7 to get negative 7. So that's our second coordinate. It looks very similar, but not exactly the same. Our third transformation is a vertical stretch by a factor of 2, which means in this case xy, all right, x stays the same, and we're going to multiply the y value by that factor. So whenever we have a vertical stretch compression, we multiply the y value by that number multiplying in this case. So here we have our neg 1 comma neg 7. Again, we take this coordinate and feed into here, and this becomes neg 1 comma 2 times neg 7 is neg 14. All right. And then finally, our last transformation, xy. When we take a vertical shift up by 8, that means xy becomes x comma y plus 8. All right. And so we're taking a coordinate of negative 1 comma negative 14. Again, making sure we process the new coordinate and run it through our new transformation. So x stays the same, so it's negative 1, and we're adding 8 to the y. Neg 14 plus 8 will be neg 6. And therefore, what happens is this coordinate of neg 6, neg 1 comma neg 6, all right, is our final point. And we'll make the statement here, all right, we'll make the statement here that probably want to make this a little smaller font. I'm going to make the font a little small here for our statement here, because I'm going to be writing something and my handwriting is terrible, as you've seen before. So a coordinate that must be on g of x is negative 1 comma negative 6. Okay, so we're going to make the statement that coordinate must be, and why? Because we have basically run this through all the transformations. Okay, all right, and let me make this full page so you guys see everything here. Well, yes, and you will have to show each of the rules for each transformation and show each step involved. If we don't, then you're basically saying you don't want full credit for the question, though. Okay. All right, everybody. Thanks so much for watching. This is our the end of our MRS22 Spring 2021 final review. This is our last question, and so hopefully, good luck with you guys on the exam. Please leave any questions or comments in the comment section below. If you found this video helpful, please give it a like and subscribe to the channel. We're so close to 200 though. All right. Everybody, thanks so much for watching. Take care, and I'll see you guys, well, maybe next video. Take care. Be safe.